We are dividing polynomials by something other than a monomial, which means more than one term. Okay? What that means is that we actually have to use long division. Okay, so I'm going to go over an example. I think we talked about it a little bit yesterday, but just to have on our paper to reflect back to help you. If you want to close the door, it is really cold. Okay, so if I pick a number like 396 and I divide it by 2. Okay, how many times does 2 go into 3? Once. And then what do? We multiply. 1 times 2 is 2. And we find our remainder, right? 3 minus 2 is 1 by subtracting, right? Do y'all remember that? Long division? Does it at least look familiar? Yes. Okay, as long as it looks familiar. Okay, then I bring down the 9 because 2 can't go into 1, right? Can 2 go into 19? Yes. Now I want you to realize too, we're paying attention to down here, not up here, right? Down here. 2 goes into 18 9 times. 19. 2 times 9 is 18. What do? Subtract. Find our remainder of 1. Bring down our next number. 2 goes into 16 how many times? 8 times 2 is 16. I subtract, and my remainder is 0. So it's a pretty number, 198. Okay? Does that look familiar? Okay, that is going to help you. What are you lost with? Well, I was hoping you knew how to do that. Okay. But what we're doing today is a little different, but a little the same. So I'm old, and the way I learned this is that the cowboy rides the horse. Cowboy on top, horse on bottom. Horse stays outside. Cowboy goes inside. Okay, one thing I do want you to write down before we move on much further. You cannot be missing degrees. And I'm going to explain what that means. You cannot be missing degrees. Okay, so you'll look right here. This is a degree of 2, a degree of 1, and a degree of 0. Is anything missing in the middle? No. 2, 1, 0, it's all, so we're good. This is a degree of 1, this is a degree of 0, nothing's missing. So on this one, that doesn't pertain to. Okay, but we will have examples we are missing things, so we'll look at those as well in a second. But I just wanted to write that down because you should always check first that they're not missing any degrees. So we're going to look here and here. Okay. So we're going to kind of think of it different because it's letters, not necessarily numbers. Okay, x times what gives you x squared? Now, what's the opposite of multiplication? Division. So could you also think, okay, x squared divided by x? Yeah, is x. Okay, however you want to think about it. I like multiplication better, that's why I think about it that way. Okay, then after we found that number, didn't we multiply it by our divisor? Yeah. Okay, so x times x is x squared. X times 3, because 3 is a part of our divisor, so we have to multiply. X times 3 is positive 3x. Everybody okay with that? After we multiplied by a divisor, what did we do? We subtracted. I have to subtract this whole thing. So subtract this and this. This first one should always cancel if you did it correctly. Okay? X squared minus x squared is 0. It canceled, so we did it correctly. Negative 5x plus negative 3x is what? And I'm going to bring down my minus 24. Now, I want you to realize there's 2 terms in our divisor, and there always needs to be 2 terms here. That's why we have to bring it down. Okay, so knowing that, Now we're paying attention to x times what gives us negative 8x. Or negative 8x divided by x is...
X times 8, negative 8.
Mm-hmm. Okay. Negative 8, so again, didn't we do 9 times 2? Yeah. Okay, so we have to do that again. Negative 8 times x is negative 8x. Negative 8 times 3 is negative 24. Then we did what? Subtract. Well, double negatives mean what? So these end up being plus. They both cancel out and our remainder is 0, which is what we like. Now there will be times where you don't have a remainder of 0, and that's okay. No, it's actually not that hard. So we'll get, the next problem has a remainder, so I'll show you. So our answer here is just x minus 8. It's dividing. That's what it is. I'm so sorry. Gerardo, you should be in camera view.
They do a whole page of work, and the answer comes out to be like 2.
I used to have to do proofs, which are math problems. Do you remember doing proofs in geometry, kind of?
Nope.
Okay, proofs are where you have to, like, prove why. Full sentences.
Oh, I hate that.
I would have, like, a whole page paper for one problem.
Yes, but no.
Like, I had a whole semester of those
And
classes.
that is why 1 equals 1.
Okay, so just a reminder, anything to the negative 1 power or a negative power means it's on the wrong side of a fraction bar. So x minus 4 should be below the bar because of that negative 1, and that negative 1 goes away. Right? Do y'all remember that?
Yeah.
Okay. So again, we're going to check that we're not missing any degrees. 2, 1, 0, 1, 0, nothing's missing, we can divide. Okay? Horse stays outside. Cowboy goes inside. X times what gives us x squared?
X.
Mm-hmm. So then what did we do?
Oh, distributed.
We distribute, we multiply, so x times x,
X squared.
x times negative 4,
Negative 4x.
and then what?
Then we subtract.
We subtract. Subtract, well, this makes a double negative, which is just a positive. These cancels, which should happen every time. Negative 11x plus 4x is negative 7x. I need 2 terms because there's 2 terms there. So I'm going to bring down my minus 3. So then x times what? What's up?
Why did the negative 4 turn to a positive 4?
Because when you subtract a negative, it's the same thing as adding. Because it made a double negative. Yeah. Okay. So x times what gives us negative 7x? You're right, it's negative 7. So then again we multiply. Negative 7 times x is negative 7x. Negative 7 times negative 4.
Negative 21. Positive 21.
Positive 28. 21 is 3. Times 3. Okay, and then we're subtracting, so again we make a double negative, and that just goes negative, so this turns into a positive. It cancels like we want. Negative 3 plus negative 28 is negative 31. I don't have another term to bring down, so this is our remainder. Okay, and what you do with a remainder is you put a plus sign, and you build a fraction. You put your remainder on top and your divisor on bottom. So our answer is x minus 7 plus negative 31 over x minus 4. Okay? Any questions? Comments, concerns? Okay, put your phones down. Every time you distract yourself, it makes it harder to learn. Look at number 4. Okay, so we've checked the degrees. 4, 3, what is it missing? Is there a 2? No, so we're missing a degree of squared. James, put your phone away. You will survive. Okay, we're missing a squared, so we have to rewrite it. X to the 4th minus 2x cubed plus 0x squared plus x minus 1 divided by x plus 1. Now, 4, 3, 2, 1, 0, 1, 0, we're not missing any degrees. Now, did that change the value of this at all?
No.
No, because 0 times x squared is just 0, right? And if I give you 0, does that change anything? No, somebody earlier said, could we put minus 0x squared? Well, yeah, if I take 0 from you, did I take anything? No, so it doesn't matter if it's plus or minus, it still doesn't change anything, okay? So knowing that, horse stays outside, cowboy goes inside. X times what gives you x to the 4th?
X to the 5th.
Okay, so then we multiply. I'm going to give y'all another second just in case you're not done writing. I burnt my tongue for lunch and it hurts now. Okay, x cubed times x.
4.
And x cubed times 1
1 cubed.
is positive 1x cubed. Then we subtracted. Subtract, subtract. X cubed minus x cubed, or x to the 4th, sorry, minus x to the 4th is 0. Negative 2x cubed plus negative 1x cubed is negative 3x cubed. My lunch was too hot. Okay, so then I bring down my plus 0x squared. So I'm going to prove to you why you have to do that here in just a second. So x times what is negative 3x cubed? Negative 3 what? X squared, actually. Because 2 plus 1 is 3. Okay? Now, if you watch, we have to multiply. Negative 3x squared times x is negative 3x cubed. Negative 3x squared times 1 is just negative 3x squared. So right here is why you have to put that placeholder. Okay? If we would not have put that here, we would have brought down an x and then had an x squared, and then when we have been able to combine our terms? No. So all that is, y'all, is just a placeholder so you don't throw yourself off and freak out in the middle of your problem. Okay? So we have to subtract, subtract, subtract. Double negatives become positives. And this cancels. 0x squared plus 3x squared is just 3x squared. Now bring down our x, because since our divisor is 2 terms, we need 2 terms at all times. So x times what gives us 3x squared? 3x. Positive or negative? Because if we just write 3x, we're missing our symbol in between. So always label positive or negative after your first term. So then we do 3x times x. It's 3x squared. 3x times 1 is positive 3x. We're running out of room. I write too big. Okay. Remember we're subtracting. And I get negative 2x. Bring down my negative 1. And this might get a little ugly. X times what gives me negative 2x? Okay, negative 2 times x is negative 2x. Negative 2 times 1 is negative 2. But we're subtracting, and that makes 2 double negatives, so we're adding. What's negative 1 plus 2? Huh? 1. Okay? Now that 1 is your remainder. So who remembers what we do when we have a remainder? Put a plus, build a fraction. Where does our remainder go? The top, and what goes on bottom? There's your answer. Okay, we're not going to do that top one on the back, just because I do want you to have time to practice today, because that's how you truly learn. Okay, so skip that top one. It's just like the ones we've already done. There's nothing different about it, okay? If you need me to do it with you, that's something we can do after class. Or not after class, but when I'm finished. Well, I do want to look at number 6, because there is something different about this one. So if you look at the top, we have 4, 3, 2, 1, 0. We're not missing anything. But what happens on the bottom? There's a 2, and there's no 1, and there's a 0. Okay, so again, we need a placeholder. So you're going to add a plus 0x in there. So you get 2x squared plus 0x minus 3. Okay, now this one is a little different because we have a number up front, but that doesn't change anything. 2x squared times what gives you 4x to the 4th power. So if you need to, you can think about it coefficient first, then variable. 2 times what gives you 4? And x squared times what gives you x to the 4th would be x squared. You're exactly right. Okay, so 2x squared times 2x squared is 4x to the 4th power. 2x squared times 0x is 0x cubed. Now, when you multiply by 0, really you would just put 0, but we're trying to make it look like terms. Okay, and then 2x squared times negative 3 is negative 6x squared. But, what do? Subtract, which I hope you've noticed has just made everything opposite sign. Okay? So this cancels, which we want. Negative 10x cubed, that just bring it down. Like I said, that 0 is just a placeholder. And then negative 4x plus 6x is positive 2x squared. Now, because I have 1, 2, 3 terms there, I need 1, 2, 3 terms here, so I have to bring down that plus 12x. So now 2x squared times what gives us negative 10x cubed.
5x squared.
So what are we missing? Negative 5. You were really close. Okay, so then we multiply. Negative 5x squared times 2x is negative 10x cubed. Negative 5x squared times 0, again, is just 0. If you want to put just 0, put just 0. Okay, and negative 5x squared times negative 3 is positive 15x. And we do what? Add or subtract? Subtract. So subtract gives me a double negative. Subtract, subtract. Well, subtracting 0 doesn't do anything. This cancels, so I'm just going to bring that 2x squared down, and that gives me negative 3x. What do I do now? Bring down your negative 8. Ah, dang it. Just dropped my top. Okay, so I have 2x squared times what equals 2x squared? Yeah. What am I forgetting? A positive one. So then 1 times 2x squared is 2x squared. 1 times 0 is 0. And 1 times negative 3 is negative 3. Subtract, subtract, subtract. And this is going to be my remainder. So when I write my answer, 2x squared minus 5, oh sorry, cubed, that should be a cubed. No, it should be squared. This should, what did I do? That should just be 5x. Sorry, y'all. Minus 5x plus 1 plus a fraction bar with my remainder over my divisor. And you don't have to put that 0 there because it's just 0.